couldn't this triangle be blown up, made larger and smaller, and it doesn't change anything, does it? So if it gets larger, the angles are going to stay the same, but the actual measurements, the side measurements, are going to be different, right? And since they haven't told us any of the side measurements, we really can't come up with a single number answer. Everyone okay? So we just need to pick the side to work with. We can either work with the leg or the hypotenuse. Your call. Which one do you want to use? Leg. Thank you very much. I appreciate it, Nancy. Okay, we're going to use this leg. Okay, so look, if this is leg, we're going to use it. Let's call it K for known. Okay, I know what that side length is, whatever it might be. Okay, so what are the two sides that we're dealing with here? Adjacent and opposite. Which trig function uses opposite and adjacent? So I'd say tan 23 is equal to x over k, and then I would multiply by k to get rid of it, and that would give me the x, right? And we're done. That's the best we can do, because we don't know what k is. Now what if instead of using the leg, we had chosen to work with the hypotenuse? What would we do differently? If the k had not been here, but had been here, if we'd chosen to work with the hypotenuse, what would be different?
God, that was so loud.
You'd be using sine. Because wouldn't we be using opposite and hypotenuse instead of opposite and adjacent? So down here, it would look the same, except instead of tangent, it'd be sine. It would still be sine of 23 is equal to x over k. And then we'd still multiply by k over here, right, to get rid of it. So it would look like k sine 23 is equal to x. Okay. The other one that was kind of a problem is number 15, and I just want to help you get that one set up so that everyone's clear on why that's a problem. If you look at number 15, it says, the communications tower is built on top of a building with the following specifications. From a point 200 meters from the base of the building, the angle of elevation to the top of the building is 23.6 degrees. The angle of elevation to the top of the tower is 15.9 degrees. Find the height of the tower. Okay, now, so basically what we have is we have the building right here. Here's the building, here's the ground. I'm staring from right there, this is 200. Okay, now what it tells us is that on top of this building, there is a tower. And if I look up to the top of the building, that angle of elevation right there is 23.6 degrees. And if I look up to the top of the tower, that angle right there is 15.9 degrees. What's the problem with that? It should be flipped, shouldn't it? Why? Looking up to the top of the tower has got to be a bigger angle than the top of the building, since the tower is built on the top of the building. Does that make sense to everybody? So let's just flip-flop the angles. Let's flip-flop the angles, and then you can work the problem. Okay, that's basically all that's needed. Now, when you do that, you're going to put the 15 over here. You're going to put the 23.6 degrees there. When I use the 15.9, I would end up finding that the height of the building, right? And when I use the 23.6 degrees, that would be the height of the building plus the tower. So how would I find just the tower? I do what? Subtract the two, right? So just come up with the answer for this, come up with the answer for this, and then subtract the two values. okay? Now, I think what they were intending is that this should have been the 26, or 23.6, and this little measure right there should have been 15.9. Why is that not what they said? They said angle of elevation. And the angle of elevation is always measured from the horizontal. Does that make sense to everybody? That's the problem with what they did. So I would say probably we just need to reverse the two numbers, or reverse the two angles and run with it that way. Okay. Any other questions about the word problems? 13. An observer from the ground at point A watches a rocket descend. The observer is 1,200 feet from the launch point B. As the rocket rises, the distance from the observer to the rocket increases. Express the measure of A in terms of B. Okay, so here we go. So if I was going to set this up, it tells us specifically, observer on the ground is at point A. The observer is 1,200 feet from B. We're going to assume that the rocket is launching perpendicular to the ground, so it launches like that. So the right angle is going to be there. Express the measure of angle A. So that angle, theta. Distance from the observer to the rocket, distance B from the observer, distance B. Okay, so what it wants to do, express the measure of angle A in terms of D. So theta is the measure, so what would I do? So I'd start off, what two sides do we know or are looking for? Opposite, or hypotenuse and adjacent, right? What uses hypotenuse and adjacent?
Subscribe to our channel.
Cosine. So I'd say cosine theta is equal to 1,200 over D. Now we are supposed to get in part A, we're supposed to get A by itself, right? So this theta, we need to get theta by itself. So don't we really want inverse cosine? The cosine inverse of 1,200 over D is equal to theta. So on the next one, it says B, the measure of angle A at B is 1,500, so you just plug in 1,500 and see what you get. And the next one, you just plug in 2,000 and see what you get. Okay. Okay, go ahead and put that, well actually no. If you're ready to turn that in, from the foot of a building L, or from the foot of a building, I have to look up towards an angle of 22 degrees to set top of the tree. Over each tree. From the top of the building,
Why don't you want to be on our YouTube channel?
okay, so here we go.
Or no, we're kidding. Playing around.
I have to look upwards at 22 degrees. Oh, well, y'all can't see that. I have to look upwards at 22 degrees. And I now, but down at an angle of depression, so the angle of depression right there is going to be 50 degrees. So the question is, how tall is the tree? Okay, so we're gonna call this, let's see, is there an easier way to do this? Because I can see a way to do it. Okay. I'm gonna cut this in half and make two right triangles. And I'm gonna call this H for the tree. And this is gonna be 150 minus H. And I'm gonna call this D for distance from the building. Okay, what, if this is 50, what is the measure of that angle right there? 40 now. Good. If this is 22, what would this measure right there be? 16. Okay, so how am I going to do this? So I'm going to say, look at just the bottom triangle right there. What two sides do we know, or are trying to find? They're both letters. H and D. What two sides are they? Opposite and adjacent. So which trig function are we using? Tan. So I'm going to say tan of 68 is equal to D over H. Everyone agree? Now let's look at this top triangle. What two sides do we know or are looking for? Opposite and adjacent also, so the D and the 150 minus H, right? So what uses opposite and adjacent? Tangent. So the other equation is going to be tan 40 is equal to D over H minus, 150 minus H. Everybody okay? Now, couldn't I get this to be an equation D equals? What would I have to do to make this so it says D equals? Multiply both sides by H, right? So I'm going to say H tan 68 is equal to D. Couldn't I do something similar on the other equation also? And get it so it says D equals, and it's going to be 150 minus H times tan 40 is equal to D. Okay. Now, if both of these are equal to D, sorry, I was just thinking about a video game, sorry. If both of these two things are thinking, we have a video game system at the house that's been broken for a while, and now I finally have time to fix it, and I'm kind of excited about it. So,
You just thought about that.
yeah, I did. I just thought about it right now. So if this is equal to D and this is equal to D, aren't they going to be equal to each other?
Can
So I
delete
can
it
say
afterwards.
H and 68 is equal to 150 and 40 minus H